This recording should be a review on how to find slope. For slope, we are looking at the direction and steepness of a line. We can calculate slope if we know 2 points, even if we don't have a graph. So the way we do that is we take a look at the ordered pairs. And remember, ordered pairs are always x, comma, y. Well, when you have two ordered pairs, it's really hard to make an expression just using x and y when there's actually two of them there. It's a bit of a problem, right? So what we do is we call this one x1, y1. We call this one x2, y2. That way we can keep track of the difference between the first and second pair. And you might remember that slope is rise over run, so we put our y's on top and our x's on the bottom. Rise over run. So this is the change in height over the change in left and right movement. So if you use this, you can find the slope of a line. Being able to identify whether a slope is positive or negative is a really important skill. One of the most common mistakes I see, probably the most common mistake that I see, is that people will get the fraction right, but they forget about the positive and negative bit. They'll end up with always positive slopes. They'll do 5 minus 8 is positive 3. Oops, well 5 minus 8 is negative 3. You should have a negative slope there. So if before you do that, you identify whether slopes are positive or negative, then at the end you can check your work pretty easily. When a line goes up from left to right, see how that's going up? That's positive. This line is going down as it moves to the right. So this one is negative. This line is also going down. So its slope is also negative. And our last one over here goes up pretty steeply. So that makes this one positive. So we are actually going to find the slope. You notice that those circles are nice and big. That's because it was really hard for me to place them exactly right, and I wanted them to cross on that line exactly. So we need to figure out where these points are. It means you need to be able to see the ordered pair here. So we always start at the origin and then move to the point to figure out that point's location. So this thing is 1, 2 to the right, and then it didn't move up or down at all, so it's at 0. This point down here, 1, 2, 3, 4 to the left, that makes this a negative 4. When we move left, that's negative value. And then it's 1, 2, 3, 4 down. So it's at negative 4, negative 4. So we're going to use y1 minus y2 over x1 minus x2. And we're going to do this to find the slope every time. So I'm going to circle that in green, and I'm going to circle that in purple. That way I can keep track of my different points. This green one I'm going to call point 1. Why is the green one point 1 instead of the purple one? Because I felt like it. You can choose the other way and you should still get the same answer. If you get a different answer, that means you probably subtracted wrong. So, y1 has to be 0 because that's the y value of the first point, and x1 has to be 2 because that's the x value of the first point. Then I'm going to subtract the other point from it. In this case, both of them were negative 4, both the y value and the x value. Zero minus negative 4 is positive 4. 2 minus a negative 4, when you subtract a negative, that's the same thing as adding. So that's 6. So this has a slope of 4 over 6. But 4 over 6 can be reduced. We can divide both 4 and 6 by 2. So we get a slope of 2/3. We have a rise of 2 and a run of 3. And we can check that. If we come up 1, 2, and then go to the right 3, 1, 2, 3, we end up on the line. Do it again. 1, 2 up, and 1, 2, 3 to the right. Sure enough, slope of 2/3. Find the slope. Slope here is positive because the line is going up as it moves from left to right. And again, I'm going to find where those points are. So that's negative 1, 2, 3, 4, 5, 6. So this is 6 to the right, and it didn't go up or down at all. So the y value is 0. For our next point, start at 0 and then go to 1, 2, 3. We went back 3, so we went to negative 3. And then we went up 1. Going up is positive. So again, I'm going to do y1 minus y2 over x1 minus x2. So I'm going to draw my fraction, I'm going to put in my subtraction signs, and now I just have to keep close track of my x's and my y's. So if I call this y1, oh, sorry, did I say y1? x1, golly. If I call that x1, that's the x value from my first point, that means it goes in here. Then this is y1, so I put in 0 where y1 was. Negative 3 is my x2, and positive 1 is my y2. 0 minus 1 is negative 1. Negative 3 minus, oh, God, I can't talk today. Try that again. Negative 6 minus negative 3. Subtracting a negative is the same as adding. So negative 6 plus 3, that's a negative 3. Negative 1 over negative 3 is the same as 1 over 3. That gets us our positive slope that we said we would get at the beginning. We said this line goes up from left to right, so positive 1/3 should make sense. For our last one, this slope is negative. I know it's negative because the line goes down as we move from left to right. So I'm going to find the ordered pair that goes with this point here, We go to the left 1, 2, 3, 4, 5. To the left 5 means negative 5 for next value. And we go up 1, 2, 3, 4, 5. We went up 5, so that's positive 5. For our next point, we go to the right 1, 2, 3, so that's positive 3, and then up 1 is positive 1. So remember that y1 minus y2 over x1 minus x2? So I'm going to plug in my x and y values. And then work on that subtraction. 5 minus 1 is 4. Negative 5 minus 3 is negative 8. 4 over 8 can be reduced. That's 1/2. But there's this negative sign here. And right now it's down in the denominator. And if you remember your fraction rules, remember that negative sign doesn't have to stay down in the denominator. It could go in the numerator, or it could go out front. The slope is negative 1/2. And there's a lot of different ways you can write that. 1 over negative 2, negative 1 over positive 2, negative 1/2. This is the way you will usually see it. So, that's our review on slope. Hopefully this helps.